All right, this lesson is focusing on chemical bonds, and we will be focusing on those through several days of this chapter. A couple things that you need to recognize is that there are three different types of bonds. There are ionic bonds and covalent bonds, and we'll spend a lot of time with those. And the third type of bond is a metallic bond. Metallic bonds, we don't spend a lot of time with those, but we should know that they exist. And the metallic bond, basically what it is a bond between two metals that are on the periodic table. So let's go ahead and get started with some of the basic things that you need to understand in order to understand chemical bonds. Last chapter we talked about chemical symbols. Basically everything on the periodic table is a chemical symbol. If you look on right here, we've got two chemical formulas. Again, formulas are showing you subscripts. Okay, so what is subscript? If you think sub means under, so each one of these numbers is a subscript. And what they're telling you is how many of each atom. So if you look at carbon, carbon has 6 atoms. Hydrogen would have 12. Oxygen would have 6. If you come over here to the other elements, or other compound we've got hydrogen with 2, and then we've got oxygen, which just doesn't have anything. Now, because it doesn't have anything, that doesn't mean oxygen isn't there. Most of us would recognize that there are 2 hydrogens and 1 oxygen. So in chemistry, we always assume that there's always 1 when it comes to missing subscripts and things like that. So again, no subscripts, you only have 1 of that particular atom. A couple things that we also should recognize here, since we're dealing with compounds, we should ask these questions, which we talked about before. Are compounds a pure substance? A pure substance is basically when there's only one thing. The answer to that is yes. They are definitely a pure substance. If you look at sodium down here and chlorine, when we put those together, we'll get our table salt. So they are definitely, when you look at these crystals right here, they're all the same type of crystal. You would taste them. They all taste the same. They smell the same. They basically have the same properties. So this is definitely a pure substance. Okay. The second question, how are elements combined in a compound? The way that elements are combined is chemically. Okay. In a mixture, they're put together, but in compounds, they're chemically combined, which means they're not easy to separate. Last question, do compounds have the same properties as the elements that create them? Again, the obvious answer to this should be no. Think about sodium metal. If you put sodium metal in water, it's going to react and possibly cause a fire. If you put chlorine gas anywhere near your skin, it's going to cause some severe burns. You put these two elements together, and they're going to form this substance here, your table salt, which we've all handled, we've eaten it, and that type of thing, and it's actually a necessary thing for life. So if you eat sodium or you ingest chlorine, it's going to hurt you, if not kill you. But if you ingest salt, that's not necessarily a bad thing unless you have too much. But small amounts are actually a healthy thing for you to have. Other things that we need to make sure we truly understand in this chapter are valence electrons. Last chapter we talked about that each group has a certain number of valence electrons. So if you look at the elements in group 1, they have 1 valence electron. Group 2, there are 2. Group 13, you basically can remove the 1 here, and you have 3. Group 14, you'd have 4. Group 15, you've got 5, and so on. So we're going to do that until we get up to 8 valence electrons. And again, valence electrons are the electrons in the outer orbital. And basically, we use them for bonding. So it's important that you're able to recognize where they are in the periodic table. So you want to get comfortable recognizing magnesium's over here. It has 2 valence electrons and so on. So those are the type of things that you should be looking at. Other things that you should probably be able to do is recognize the number of electrons off from the atomic number. So lithium has an atomic number of 3. It has 3 electrons. And remember, the 2n squared rule will tell us how many electrons each energy level can hold. Also, you can look at some of the periodic tables, and they will tell you how many electrons are in each energy level. So the first one here can fit 2. Second one, we'll put our remaining one there. We have 1 valence electron, and we'll put 1 dot there for that. Let's look at sodium, which has 11 electrons. First energy level can hold 2. Second can hold 8. And I've got 1 last energy level here. So that gives me 1 valence electron. And so when I do the electron dot diagram, I've got 1 valence electron. Again, I wouldn't necessarily have to go through all these steps of getting there. I could just look at my periodic table, recognize it's in group 1, and say it has 1 valence electron. Okay, let's skip down a couple here. Let's go to boron. Boron has 5 protons, so it also has 5 electrons before it reacts. It has 2 in the first energy level, 3 in the second. So because it has 3 here, it's got 3 valence electrons. So when I do the dot diagram, boron's going to have 3 dots. Again, make sure you spread out your dots. You shouldn't have any more than 2 per side. Aluminum is going to have 13. So we've got 2, 8. So I'm up to 10, and I'm going to put my remaining 3 right there. Again, 3 valence electrons. It's in the same group as boron. So aluminum is going to have 3 dots. Just be sure to spread them out. So you can go through these steps, or you can just look on the periodic table and see where they're at. The octet rule is a rule that we should know fairly well also. All atoms tend to gain, lose, or share valence electrons until they have 8 valence electrons. And that's true for almost all elements. And there are a few exceptions. Our 2 main exceptions are hydrogen and helium. They're very comfortable having only 2 valence electrons. Other elements, lithium, beryllium, occasionally boron, they could be satisfied with only 2, and they meet something called the duplet rule. But basically, they would only need 2 valence electrons. And things that we're going to do with these valence or make bonds with them. So if you look on this bond right here, this is carbon dioxide, and we've got 2 oxygens and 1 carbon. And if you look at it, the valence electrons in red are the oxygen valence electrons. We have 6 of those. Ones in black are the valence electrons for carbon. So in this particular bond, to get to 8, they've got to share electrons. So they're meeting the octet rule. So if I add up these electrons right here, I've got 1, 2, 3, 4, and 4 on the other side. So I've got 8 electrons right here with carbon. So it thinks it has 8 electrons, and it's pretty happy with that. And each one of these oxygen atoms, if you add them up, will also have 8 valence electrons. So we're meeting the octet rule, and we'll learn how to draw these throughout this chapter. Another way that we can meet the octet rule is basically just to lose our valence electrons. So sodium has 11 electrons total, 1 valence. If it loses that 1 valence electron, basically its outer shell before would be full, because remember, sodium, we've got our protons and neutrons in the nucleus. We've got 2, 8, and 1. This 1 valence electron, if I can get rid of it, I'm left with 8. That would satisfy my octet rule. So it's going to go ahead and get rid of the 1 valence electron, and it's going to send it over to chlorine. Now, chlorine's got 7 valence electrons. If it gains 1 more, it would have 8, and we can see that this would meet the octet rule.